students, welcome. We are on the CEC Gurukul platform and we are in the series of experimental physics where we are discussing the optical experiments. And in today's lecture, we discuss about the diffraction grating experiment. I am Dr. Sonia Bansal from JC Bose University of Science and Technology, YMCA Faridabad. We start with the aim of the experiment. What is the aim of this experiment? The aim of this experiment is to measure the wavelength of spectral lines of mercury source by using the diffraction grating and spectrometer. This represents that we are getting the spectrum by using the mercury source and we are calculating the wavelength of these spectral lines by using the diffraction grating. So this experiment aim is to measure the wavelength of spectral lines of mercury source using the diffraction grating and spectrometer. Now, who discovered this experiment? Who gave this diffraction grating? The principle of diffraction gratings were discovered by James Giroux, who defined the Newton's prism experiments initially with the item such as bird feather, and he gives the output. The first man-made diffraction grating was made by the inventor David, who turned hairs between the two finely threaded screws. It means we are having the this grating having the different slits. Here, what is this diffraction grating? This is the main question in this experiment. What is this diffraction grating? Diffraction grating consists of a large number of equally spaced parallel slits. As we see that this is the boundary, right hand side. On left hand side, this diffraction grating we use in the laboratory. This diffraction grating contains a glass plate on which parallel equidistant lines are marked at a particular diamond. This arrangement is very costly as we put a equidistant line by the diamond. So the replica is created for this. How we create a replica? We take a colloidal solution and spread this colloidal solution on this glass plate, and then we sketch out. It is like a polyfilm, and this polyfilm is sandwiched between the two glass plate, and the mark is printed on this colloidal solution film, and this film having the parallel lines equidistant, one work as a slit and another work as a opaque region. So we are having a number of lines, equidistant line in this diffraction grating. We are having 15,000 lines per inch in the diffraction grating. So in the left hand side we are having the diffraction grating which is having the equidistance line, and these lines work as a slits. So we have a number of slits in this diffraction grating. Now you see that this diffraction grating, on the left hand side the beam is passed through the distance between the two slits represented by the d, and the beam which is deflected through this diffraction grating makes an angle theta. So the path difference between the ray from any two adjacent slits is represented by del is equal to d sin theta. So two adjacent slits having the path difference of theta, del is equal to d sin theta, and interference maxima occur when this d sin theta is equal to n lambda, m is equal to 1, 2, 3. Then we can get the constructive interference. Now, if del is equal to some integer multiple of the wavelength, then wave form from all the slits will arrive in the phase at a point on a distance screen, and we can get the maximum output. You see on the screen that here we are having the two type of output, two type of diffraction, and these two diffraction are not same. Here we see on the upper side we are using the diffraction grating, and on the lower side we are using the prism. We see through the diffraction grating beam will be diffracted right hand side and left hand side, and the central beam will be of the same wavelength of the light or the phase, so we can get the maximum light. So at the center we can get the white light because all the waves are in the same phase. But on the right hand side we can get, or also we can get the left hand side maxima through the diffraction grating. But here by using the prism we are getting the spectrum at the one side. So diffraction is not same as the refraction. Now this diffraction grating intensity distribution, just a graph is showing here. D sin theta is equal to m lambda. So m value may be 0, 1, 2, it is plus minus, so minus 1, minus 2. In this manner the intensity maxima are brighter and the sharper than for the two slit cases, and we can get the maximum output. Now see here, the light from the source pass from this diffraction grating, then they are diffracted towards the screen, where the central we can get the principal point where we can get the maximum output, and this is called the central maxima. And on the right hand side we are getting the first order. At the center we call it as a zero order, which is defined as m is equal to 0. And on the right hand side we can get the first order, which is represented by m1. And on the left hand side again at the bottom we are having the first order maxima, which is represented by order 1. So order 1, n is equal to 0 order, we are getting the first order on the both the side. The distance between the two orders represented by y. The distance between the diffraction grating and the screen represented by the L. So this is the schematic diagram of the diffraction grating experimental output. Now see here, the light from the source from the left hand side pass from the diffraction grating, it is represented by A, and then from here it fall upon a screen, then we can get the output. Here on the right hand side we are seeing that central white we get, it is a 0 order maxima, and on the right hand side first order rainbow, on the left hand side first order rainbow, that is a bright maxima. First order is bright, other two the second order on the both the side having the faint output. So we can get the maximum intensity output on both the first order. At the center we are having the white light. Now working principle of the diffraction grating. The diffraction grating is useful device for analyzing the wavelength of the light sources. It consists of large number of equally spaced parallel slit through which light can be diffracted. Its working principle is based upon the phenomena of the diffraction. Now in the working principle we are having the space between the lines which acts as a slit. The line represent the opaque region, and the space between these two lines represent the transparent region, and it works as a slit. And these slits diffract the light waves, thereby producing a large number of the beam that interfere in such a way so to produce the spectra. This is also called a transmission grating, which can be made by cutting the parallel lines on a glass plate with a good precision ruling machine, so that we can get the 15,000 lines or more. It depends upon the requirement, we can produce the transmission grating. The space between the lines transparent to the light and hence act as a separate slits. The reflection grating can be made by cutting the parallel lines on the surface of the refractive material. This grating that have many lines very close to each other and can have very small slit spacing. Now one thing is that the spacing between the lines should be over order of the light fall upon it, so that we can get the interference pattern, diffraction pattern, and we can get the good output. As the light which we are using may be sodium lamp, mercury lamp, we can use the laser light also, but the lines which we are drawing, the distance between the lines must be order of the wavelength of light which we are using. That's why we can get the output diffraction of light. A plane wave is an incident from the left normal to the plane of the grating. Then by using the converging mirror, it brings the ray together at the point P, where we can get the maxima. The pattern observed on the screen result of the combined effect of the interference and diffraction pattern. But here through the diffraction pattern we can get the results. Each slit is produced diffraction and the diffracted beam interfere with one another to produce the final pattern. And then we can get the first order maxima, second order maxima and the zero order maxima. The wave from all the slits are in a phase and they leave the slit. And at the center we can get the maxima. Some orbital direction is measured from the horizontal. The waves must travel different path lengths before reaching the point P. So from the figure we can note the path difference del between the rays from any two adjacent slit, which is equal to d sin theta, as previously we mentioned. So del is equal to d sin theta. If the path difference is equal to the wave or some integral multiple of the wave, then they must be in a phase and they reach at a particular point as represented by the P. The bright fringes will be observed. Therefore, the condition for the maxima in the interference pattern at an angle theta is defined by sin theta is equal to del is equal to d sin theta. You see, on the point P we can get the maximum. Through the convergence line we can get the P point as a maxima. Now for the diffraction grating formula, if all are in phase and we are getting the maxima, then the formula is d sin theta is equal to m lambda, where we can put the value of m is integer, which may be 0, 1, 2, 3 and 4. This expression used to calculate the wavelength if the grating spacing or grating element we will know. Then the angle is equal to theta, as this is theta is equal to 0 as all are in phase. If the incident radiation contains the several wavelengths, the mth order maxima for each wavelength occur as a specific angle, and then we can get the light diffraction pattern on both the sides. Then what is the formula? As the wavelength are seen at an angle theta is equal to 0, corresponding to m is equal to 0. The wavelength we get is the maximum white light output, and that is the 0 order maxima. M is equal to 1 observed at an angle that satisfy the relationship sin theta is equal to lambda d, that is the first order maxima. For the second order maxima, m is equal to t, that we can observe at a larger angle theta and so on. It is representing that when the value of theta is equal to 0, we can get the maximum. That is represented by the 0th order, and the value of m is equal to 0. When at a small angle, and then m is equal to 1, and the sin theta is equal to lambda by d, that is the first order maxima. For the second order, m is equal to 2, and we observed it for a large angle and so on. The maximum the order we can get at a maximum angle is 90 degree. Beyond that we cannot get any order or any output. So maximum value of theta is equal to 90 degree. At 0 we are getting the 0th, at a particular angle we get the first order, then at a larger angle we can get the second order. So in this manner we can get the 0, first, second and third. You see on the screen that here the center bright light which is the mercury light. On the right hand side we are getting the first order spectra. At the middle we are having the 0th order. On the right hand side we are having the spectra which is the first order. On the left hand side again it is the first order. Of the first order we are getting the fainted second order spectra. Similarly here on the both the side. This is the output we are getting through the diffraction grating experiment. Light slit should be narrow. So what apparatus we use in this diffraction grating, which is essential requirement? Spectrometer, through which we can get the readings, mercury source, spirit level that will adjust the spectrometer, then reading lens through which we can read the reading. So this is a spectrometer. The spectrometer instrument used to measure the spectral components of the physical phenomena. You see that in the middle we are having the diffraction grating, and it contains the two part. One is telescope, another is the collimator. We put the collimator near to the source of light. Now the spectrometer has the three component: collimator, telescope and prism table. Prism table or diffraction grating table. Now grating table, where we can put the grating and we adjust the grating through the grating holder. The collimator, which is very near to the source and having the slit which can be closed and open to pass the fine light towards the grating. We use the telescope to get the output, spectrometer base through which we can read the reading, and the platform to which the grating table can be clamped. So this is the arrangement. Screw for focusing the collimator, screw for adjusting the width of the slit so that a fine slit pass through the diffraction grating. Screw for the focusing the telescope, we can leveling the screws or the base of the spectrometer. Spirit level which will adjust the spectrometer, reading lens which used to read the reading through the two scales of the spectrometer. This is the grating which is also called the diffraction grating and the diffraction grating, and this is the periodic structure that splits the lights into the several beam traveling in the different direction, and it is a glass plate which is marked with the parallel equidistant lines. The grating, we use the mercury lamp also. A mercury lamp is a gas discharge lamp that used an electric arc through the vaporized mercury or produce the light through which we can get the pattern. If we use the mercury light, then we can get the spectrum. If we use the laser light or a single wavelength light, then we can get the only the same color light, but different orders we can get. Like central will be the bright, and right hand side we are having the lesser bright, and on the second order is also a fainted light we can get. So in this grating we are having a 15,000 lines per inch, that is equal to 0.254 meter. By using this we can find out the grating element. So number of ruling per meter on the grating, n is equal to 15,000 divided by 0.0254. So we can see that at a 1 meter per meter we are having the 590,551 lines. That is a 5.9 10 to the power 5 lines per meter having this transmission grating. What is the procedure? The three main components we have to be careful. The procedure may be divided into three parts. One is the adjustment of the spectrometer, second adjustment of the grating, third is the actual experiment procedure. Follow this output. Now in the first step we level the base of the spectrometer by using the spirit level. Then we using the screws we adjust the prism table, focus the collimator towards the lamp, and adjust the slit width so that we can get the sharp light, high intensity, so get the sharp and bright image of the slit. Focus the telescope at infinity, turn the telescope round to keep it in line with the collimator. Means the collimator, the eyepiece, telescope and the grating should be at the same line so that the output can be get easily. Level the base of the spectrometer using a spirit level and with the appropriate screws. Focus the collimator on the lamp and adjust the slit width so that we can get the sharp bright light image. And then we can have the telescope around to keep it in the line, and collimator to ensure the vertical cross wire of the telescope which falls centrally the image of the slit when we see through the telescope. For the fine tuning position of the telescope, clamp its base and use the screw for the tuning. And the grating table using the appropriate screws and clamp it through proper heights. Grating at the center, and we adjust the grating and turn the black platform black around so that the light from the collimator falls at the right angle on the grating, and then we can get the output at the various angle. By adjusting this, we can get the diffraction grating. This is the observation table for the angle of diffraction, through which we can get the reading. First, left hand side we are having the orders. We are getting the zero order, first order and second order. So zero order, the same light as the mercury lamp, the white light we get, we note that reading. Then first order, green, yellow and red light we note. As the spectrometer having the two scale, V1 and V2, so both the scale we can get. Moreover, we can get the both the side, left hand side and right hand side, both the reading we can get, and then we can get the mean of that. Again at the second order we can get, and it is difficult to get it. What is the precaution? The grating should not be touched with the hands and rub again because of the dust. Grating should be perfectly normal, axis of the collimator. Turntable must be leveled optically, and the slit should be narrow as possible. All preliminary adjustment of the spectrometer must be made before starting the experiment. While taking the observation, the turntable must remain clamped. Reading both the vernier should be taken so that we can get output. Source of error we can calculate. Spectrometer is if not properly adjusted. If reading is not taken here to the spectrophotometer, reading may be taking the care of precautions by using the reading lens. Thank you very much.